Okay, so I'm going to have a look at programming the little blue pill. It's got a STM microcontroller on there, 8 megahertz crystal. It has a little interface for SWD programming and debugging. And I'm just going to use here, I just happen to have an F4 discovery board from ST. So if you have one of these ST discovery boards or one of the Nucleo boards with an ST Link hardware on there, we can use that. So essentially, if that's hooked up to the computer, and we'll see that connect in a minute, you want to remove the ST Link, these little linky bad boys, because these are used to say we want to connect the ST Link to the onboard microcontroller, and we don't. We want to connect it to our BluePill device, so we'll take that off. We'll have a look at the connections here that we've made. So on the SWD device, we have this header, which has some various bits and pieces, and we have the little header here. We'll show you in the diagram how this is connected up here. I've just used a couple of little jumper leads. I have a power supply as well, because we want to separately power our BluePill whenever we're doing the programming and so on. But the first thing we'll do is create a program. Our STM32 cube. We start that up, and what we want to do is choose a program that choose the part that's on this BluePill device here. So on here we've got a STM32F103. So if we go into the MCU selector, and that will allow us to select which chip that we have. So we'll start off up here and we'll type in STM32F103, and it's a 103C8, so we type a C as well, and we choose the C8. So this just gives us some information about it, and this is it here. It's the LQFP48, and we'll start the project with that. We're happy with that selection. So this gives us our chip, and we can go in and set up some of the things here and generate some basic code for it. So what we'll do is we'll go into the system here, and first of all we want the serial wire debug, because that's what we're using, the SWD between our discovery board or any SWD or ST Link unit that you have and our little BluePill circuit. So we'll choose serial wire there, and happy enough with that. The next thing we do is we want to set up the clock. So we want the high-speed clock, crystal ceramic resonator. This board will run it up to 72 megahertz. So when we've selected that, we can actually go into clock configuration, and if we choose here our 72, it will say that there's no solution found at the minute. Do you want to use other sources? We say OK. So that just reconfigures the internal hardware and so on. So as you can see, the input frequency is at 8, so that's 8 megahertz crystal, which is what we have on our BluePill, and it results in our H clock or system clock of 72 megahertz here, which is what we want. So it's running as fast as we can get it to run. So we go back to the pin configurations. This pin here, which is port C, pin 13, is actually connected to the little green LED that we have on our BluePill. So we're going to write a bit of code that flashes this LED, which is what we want to do. So in order to do that, we have to set this pin. If we click on it, we can set the pin as a general purpose I/O output, because we want to drive the LED, so we need a signal coming out from this. And once we've done that, we can go in and actually see our GPIOs, and we can configure them. So the output level to start off when we boot up is low. That's fine. It's a push-pull mode, so it can actually drive and sync current. We don't worry about a pull up or pull down for this application, and we'll just say that we're running it at high speed. So that's probably the least power saving mode, but we're not worried about that in this application, although we're probably not driving at that high speed anyway, but later on we might want the output some faster signals and look at it with a logic analyzer or scope. So just to make sure that we're driving it correctly, we'll just choose high here. Okay, so when we're happy with that, essentially we've set up our debugging mode, our clock, set one of our pins to an output. So let's generate some code here. Oh yeah, we need to go in and actually go into the project manager and define the project name. So I'm just going to call this BluePill Blink, and we'll just stick it on the desktop. So it's a basic program. Whatever tool chain you're using, if we select it here, I'm going to use the MDK ARM. These settings are fine for heap and stack for our basic program. And that will do us. So if we now generate the code, so it generates user source code in the project files that we need. So okay, so we can open the project straight away and it'll open it up in Microvision. So we want to see our application folder, and if we go into the main, we'll see that it has generated some code for us. So this code has been automatically generated, and it has the clock configuration code and the GPIO code. So this sets up the clock and so on, as we requested for 72 megahertz. This one here then will set up the GPIO or PC13 that we set up. So these are just the function prototypes. Obviously they're actually called down in the main function. So if we go into the main function, we can see we set up the HAL, we set up the system clock, we call that function, and we've called the one to set up the GPIO. So once we've done that, we have a while one loop in here, which just goes round and round. We'll take out those placeholders and we'll stick in some code. So what we'll do is we'll toggle the pin that we've set up as an output every sort of second, for example, to start off with. So if I do HAL GPIO, and I can toggle pin, which is a function. Now you'll see that it's actually given me from the function prototype the parameters that it expects me to pass into this function. So what it wants is the GPIO or the port. So we can use GPIO-C, and here then is the pin number, which is defined as a GPIO pin 13. So if we do GPIO-C, you can see it's suggesting that, and then we do GPIO pin, and then we select the number of the pin that we're using, which is pin 13, and that will actually toggle it, which means if it's off it'll turn it on, if it's a 0 it becomes 1, if it's 1 it becomes 0. So it just inverts the state that it's at. And then if we were just to go around that while loop, it would be far too fast for us to see. So we need to put a delay in. So we'll put a delay of 1000. So that means it'll change state once every second. Okay, so once we've done that, we can build it. So we go up here and hit build. You'll see it building down at the bottom. So it goes through and compiles. So this will actually generate a hex file that we could load onto the BluePill. Now I had some problems initially in actually getting this to work. It was coming up with various problems and so on. So I do advise you to go and download, for example, the latest version of the ST-Link utility from ST from their website, and then actually update the firmware. So I'll just go through that process to show you how I've done that. After I downloaded it and installed the latest version, so you want to make sure you've got the latest version running. We'll just start it up. So we go into ST-Link, firmware update, and if we do device connect, so you want to make sure that your ST-Link is connected to your computer at this stage. And device connect, okay, it's not in the DFU mode, please restart it. So to do that, I'll just unplug and replug it in, and then I'll hit device connect. Too quick, try it again, there we go. So it's saying that the version at the minute, current firmware is version 2 J34S0, which in sort of mid 2019 is the latest version. It's the STM32 debugger. So we can actually see that I've already done the update, but anyway, we'll upgrade it just to show you what happens. So you hit yes, that'll do the upgrade, and it just goes through this process here and updates your device. So I would highly recommend that first. So the next thing that we can do then is we can load the hex file directly into the BluePill if we want here. And so to do that, I will select target. Now if we go to settings, you'll see this is our ST-Link serial number, and we've just got normal and hardware reset. So if we hit OK, so it can't connect to the target. If we can't connect to our target here, one of the things that we'll want to do is power it up. So that's important. So we'll just plug the power supply on this side, and you can see it's powered up. So target, connect, and we've got connected. Okay. So if we just open a file, open the hex file that we want. So if we go to desktop, BluePill, ARM, blink and hex, and that gives me the hex file that we want. And then I can do target, just check we're still connected, yep, and then target program. So this is the hex file, and we just hit start. And it says that it's been programmed in 1 second, 110 milliseconds. So now that it's programmed, you'll see that it's flashing here. Might have been flashing before because I've ran this program before. But what we'll do now is we'll go in and we'll actually speed this up a lot. So and we'll debug it from Microvision. So if we go into Microvision, one of the things we can do is load it from here. So if we hit load, so we have to choose what we're doing. So if we go into the options for the target and under debug, ST-Link debugger, look in under the settings, go with connect normal auto reset. Okay. Okay, and try loading it. We need to power it on again, of course. My power supply has an automatic timeout of it, and this is too low of current flowing. So anyway, if we hit download, it has finished programming, and you'll see here that it's actually in a reset state. So if we hit the reset button, it starts running the code. So what we'll do, we'll make a modification. We'll make this 50 to make it really fast. We'll build it. Should build a lot faster this time. Yep, it's complete. And then we'll load it down onto the board. So you see it loading. And if we reset this time, you can see that we've got a much faster flash rate. So another thing that we can actually do as well is to debug. So if we go to debug, start a debug session, and what we'll do is we'll just create a breakpoint. So we'll create a breakpoint after each time it's toggled. So we'll put a breakpoint there, and then if we do debug run or hit F5, so it'll run to the breakpoint here, and then if we run it again, it'll run again to that breakpoint, but we'll have toggled. So if we hit run once more, you'll see that the light comes on now and stays on, the little LED here. And if I do it again, so we can actually do full debugging through this simple connection, and we can look at variable names and get output and so on, which we'll look at in some of the future videos. So I hope this has been helpful. If you like it, give it a thumbs up, and if you like it, give it the thumbs up, and do subscribe, and I'll create some more videos. That encourages me to make some more videos about this type of thing. So hopefully that was useful for you, and we'll speak again soon. Cheers, bye.